How's it going, guys? So today I'm going to show you how to easily make complex AI within Blueprints. So let's get started. First thing you're going to want to do is find an empty space inside of your project. I've actually created a new folder and I've named it New AI. And what we're going to do is we're going to get the setup part of everything done first before we even touch the blueprints. So the first thing we want to do is create an enumerator. So if we right click and go to blueprints and go to enumeration, let's go ahead and call this EAI states. And we're going to go ahead and open this up. And so by creating an enumerator, we're essentially creating a state machine for our blueprints. And by doing this, it keeps our blueprints nice and clean. There's not a whole bunch of booleans. We only have to manage these different AI states. So let's go ahead and create some different states that we'll need for our AI. The first one I'm going to make is called make decision. And this is actually the most important one that we'll be creating, and I will show you why later, but we'll go ahead and start with that. Next thing we're going to do is stop brain. And then we're going to actually create the different states here now. So we're going to do move to target. We're going to do one for attacking. I'm going to do one for patrolling. I'm just going to name this attack instead of attacking. Then let's do one for face target. Let's do one for dodging. Name it dodge. Let's do one for strafing, in case we want our AI to strafe. Let's see, let's do one for projectile attack. And then this should be good for now. I'm going to actually move this stop brain up here at the top. And let's go ahead and save that and then move on to creating the next thing we'll need. Next thing we need to do is create a data asset for our AI. And a data asset, what it essentially does is it stores a bunch of different variables that are unique to that specific AI. So what we can do, we can right click if we go up to blueprint class and search for primary data asset. Let's go ahead and select that, and we're going to name it DAAI. Let's go ahead and open it up. And so here we're going to create a bunch of different variables for our AI. Let's start by creating a variable for health. So this will be how much health our AI has. Let's see. Next, we'll create one for default movement speed. Next, let's create stuff for animations. So what different animations will we need? We'll need attacking animations. And let's go ahead and convert this into montage. And then over here, we're actually going to convert this from a single into an array. That way we can store a bunch of different animations to be played. Let's see, we're also going to need some animations for when the AI is patrolling. So patrol animations. We're going to need one for hit reactions. Hit reaction animations. Let's do one for death animations. And let's see, this should be okay for now. We can always come back in here and add more as needed. But with this created, now what we can do is create a secondary primary data asset, which is essentially a child of this, and then we can create a bunch of those for all the different AI that we want, and we can adjust those parameter for each one. So if we right click and then we go to miscellaneous and then data asset right here, we're going to search for DAAI, the one we just created. So now I'm going to call this DA Let's just call this new AI. So this one will be the specific one for the AI that we're creating. And then for any other ones, you would just do the exact same thing, but name it something different. And if we click inside of here, we can see all of those variables that we just created. So for the health, let's go ahead and set this to 100. For default movement speed, let's set it to something like 300. So it won't be too fast, but it'll just give us a starting point. And then for all the animations, we're going to hold off for the moment, but we will return. Okay, so now that we have the setup out of the way, let's go ahead and create our actual AI blueprint. Let's go ahead and right click, go to blueprint class, go to character. I'm going to call this BP AI master. Let's go ahead and open it up, and then let's assign it a mesh for the character. I'm going to search for the default character that comes with Unreal Engine, the third person character. So if I search for Quinn, and then just make sure, okay, I believe this should work. Okay, so it's not exactly the default. It's got different coloring, but it should be fine either way. Let's go ahead and fix the location of it. So I'm going to type in -90 on the Z, and then I'm going to go ahead and rotate it so it's pointing forward. There we go, and compile. The next thing that we need is to add a pawn sensing component so that our AI can actually sense different characters to interact with. So if we hit on add in the components tab and go to pawn sensing, and then if we click down here, we can adjust all these different parameters for like the hearing threshold, sight radius. I'm going to leave all this as default for now, but I am going to add an on-see pawn event by clicking this plus right here. That way, whenever it sees something, we can set whatever it sees as a variable. So let's go ahead and right-click on this pawn input pin, and then we're going to name it target. Right-click and promote to variable, sorry. And then immediately after it has set a target, I only want it to do it once until, like, let's say the AI, like the character gets out of the AI's range, and then we'll reset it then, but we only want it to do it one time. So we're going to create a branch. We're going to right click and promote to variable, and we'll call this target acquired. And then immediately after that, we're going to set this target acquired to true. That way it blocks any more. Okay, so now let's go ahead and import that enumerator and the data asset that we created by clicking plus. And then let's call this one AI data. And then we're going to do search for DAAI. So here it is. Let's go ahead and compile that. And if we look over here, we have a spot to insert the new one that we just created, which is DA new AI. There we go. And if we drag this into here, we can actually pull those variables that we created for the AI. So if we type in health, we can get whatever health we set it to and use that inside of this blueprint. So for the moment, I'm just going to move this up here, and then we're going to bring in our enumerator. And we'll call this one AI states. We type AI states. So there it is. Let's go ahead and bring this into our blueprint, and then we're going to pull out and search for switch. And then with a switch, what this allows us to do is whenever it receives a signal, we can have it go through any one of these branches that we want it to. So let's go ahead and drag this over here. The next thing we're going to want to do is create a timer. So let's right click and we're going to search for timer by event. Let's go ahead and set the time to something like 0.2, and we're also going to set it to looping. And then we're going to drag out of this event and type custom, and then we're going to name this one AI brain. And then lastly, let's go ahead and promote this return value to a variable, and we're going to name this AI brain handle. That way, with this, we can stop the timer anytime we want to. But essentially, why we've created a timer is if you're using event tick, it's expensive because it's ticking every frame. But if you use a timer and you only have it set to go, fire off an event every 0.2 seconds, it's going to save you a little bit of performance. And with a timer, it's also just easier to control. So with this, let's go ahead and wire this into our switch. And then now let's do right click and search for event begin play. And let's wire that up to our timer. So what's the first thing we want our AI to do once it spawns into the world? We probably want it to start patrolling around. So what we can do is take our AI states variable that we created here and set it to patrol on begin play. So the first time it fires off, it's going to start this timer. It's going to set our state to patrolling, and then it's going to go into our switch right here. Okay, so let's go ahead and start our patrolling logic. Okay, so whenever the character first spawns into the map, what we want to do is set its initial location. So if we go to event begin play, we're going to right click and search for get actor location, and then we're going to promote this to a variable, and we're going to call it starting location. Let's go ahead and wire that up. And so let's go ahead and create our patrolling logic. And the reason we created a starting location is we're going to be using this node called get random location and navigatable radius. So if we were to just wire up get actor location into this, whenever we move the actor around, so after this, what we want to do, we're going to search for AI move to. So if we were to do this and wire this up this way, essentially it's going to get the current location of wherever the AI is at, and then it's going to search for a radius that the AI can navigate around. I'm going to set this to 2000 here. So essentially, if we were to do this, it's going to get the current location of the actor, and so if it's basically resetting from its current location every time. So it could theoretically wander into a completely different section of the map that you don't want your AI to move to, and by setting a starting location, it's only going to find a location around its initial starting position. Okay, so what we want to do, let's go ahead and set the pawn to self. Okay, so now that we have our patrolling logic, what we want to do, every time something fires through here, you have to remember that it's ticking on a timer. So it's firing every 0.2 seconds. And if we were to just wire this straight into here, it's going to be doing this logic every 0.2 seconds, and it's probably going to be moving, sporadically everywhere, and we don't want that. So in order to fix that, what we have to do is set this AI states to stop brain, just like that. So that way, once it fires through here, it's going to fire through stop brain, which doesn't have any logic, and then it's going to continue on and then find a location to move to. And then once it has found a location, we're going to set a delay. And this is just for testing. Once we actually get into the weeds, we're going to play animation. We're going to do play montage. But for right now, I'm just going to set it up with a delay just so we can see and make sure that our logic is working. I'm just going to do a 1 second delay. And then once that is finished, we're going to change the AI state to make decision. Okay, so what we want to do with this make decision, the first thing that we're going to want to do is check and see if the character or if the player is within range for the character to start pursuing them and attacking them. So what we can do, let's go ahead and get our target variable. We're going to search for get distance to, and we're going to wire it up to other actor. We can go ahead and leave target as self since it is the AI that it is measuring the distance to. And then what we can do, we're going to do a search for greater than or equal to. And then it's essentially asking, is the player farther than this distance? And so let's go ahead and promote this to a variable, and we'll call this engagement range. Let's go ahead and compile that. And then I'm going to set this to something like 2000. Let's create a branch. And then let's go ahead and wire this up here. And then same principle applies here, where once it fires through the make decision, we want to also stop its brain. That way it's not firing repeatedly. And so if it's further than the combat range or engagement range, what we want to do is just take, I'm going to go ahead and duplicate this, and then we're going to set it as patrol. So if he's out of engagement range, it's just going to continue patrolling. And then after this, if it is within a range, what we can do is duplicate this again and set this to move to target. That way you can start moving towards the player to attack them. And so let's go ahead and set up that move to target logic now. I'm going to scooch this down here. I'm going to search for AI move to. And so with the move to target, this is going to be the only exception that we have in terms of not stopping its brain, because we want to have the AI update its location as it's moving to the player continuously. So we're just going to not set that here, but we are going to set the pawn to self. And then let's go ahead and promote this destination into a variable. I'm just going to leave it named as destination. I'm going to check stop on overlap. And then once it reaches its destination, we can take our AI states here, and then we're going to set that to attack. That way, whenever it reaches within range of the character, it's going to attack it, and we can actually set that range here with acceptance radius. So same thing, we're going to promote this to a variable. And then up here, where we're telling it to move to the target, we can set the acceptance range before we switch it to move to target. So let's say I want the character to attack the player if it gets within 100 units. Okay, so that should work. So we've done a lot of work now. Let's go ahead and test this out. Let's hop into our level. I'm going to first compile it. And first thing we need to do is add in a nav mesh bounds volume. And I'm going to just stretch it the entire, I'm just going to encompass this entire thing here. And then let's go ahead and build the navigation data for it. So if we go up to build, and then click on build paths. And then if we hit the P key, it will actually show us in green where the AI can navigate to. So that works for me. Let's go ahead and add our AI to the level. And I'm going to set him kind of far away from where we're starting at, just so we can observe him. Okay, and as we can see, he is navigating. Except he's not moving around. Okay, there's some bug in here. Let's figure out what's happening. So first thing we need to do to fix this is to make sure that our target is actually valid or not. So if we take this and we right click and convert to validated get, we're going to set this here. So if we have a valid target, we're going to go through here and then, do it this way. If we don't have a valid target, we're just going to go straight to patrolling. And there we go. Now it's working. Okay, so let's continue. Okay, so now that we have our patrolling logic done, what we need to do is make it so whenever the AI senses the player and sets the target and sets this as acquired to, we want to switch the state so that it will pursue the player. So we can set this AI state here to make decision, and then it will fire through here, and then if the player is within attack range, it's going to set the radius, it's going to set move to target, and then we're essentially just going to get our target's location, get actor location, and then we can set the destination here. That way they will continually update their position instead of just going to the location one time. So let's test it again real quick. Okay, so as you can see now, he's actually following me until he gets within that 100 acceptance radius. So next thing we need to do, we're actually going to start working with event tick. Let's go ahead and right click and search for event tick. So we're not going to be using event tick for much. We're basically just going to be using it for whenever the character is on his way to the player to attack them. We want to update the rotation so that it's smooth, like the AI rotates smoothly towards the character. So what we should do for here, let's go ahead and get target, get actor location. And so what we need to do is we need to find the look at vector for our AI. So let's right click, type in look at, find look at rotation. For the start, we're going to get the location of the AI itself. So we'll search for get actor location. We'll go ahead and feed that in there, and we're just going to leave target as self. And then here, we can set this to the target. And then we don't want him to rotate in all different axes. We only want him to rotate on the Z axis. So we're going to split this structure pin here. And then we're going to set the AI's rotation. So set actor rotation. And then split this structure pin and only wire in the Z. And then lastly, we only want this to fire off if he's actually moving towards the player. So what we're going to do, I'm going to scooch this over here, and I'm going to create a branch. And then I'm going to promote this to a variable, and we're going to call this look at actor, or look at target. And so whenever he starts moving towards the player, we can set that to be true. And then once he has reached the player, we can set that to false. All right, cool. So now let's go ahead and set up some logic for the, we'll create an animation graph for our character here. And then we're going to set up a default slot so we can place some animations. So let's go ahead and do that now. Let's go ahead and click on our character, and then if we click on this folder icon here, it will navigate to where they're at inside the project. Then we're going to right click on them and then create animation blueprint. And I'm going to name this ABP new AI. Let's go ahead and open it up. And it's going to open us up to the animation graph. So the first thing we need to do is create a state machine. So we're going to right click, search for state machine. And I'm just going to name this locomotion. And then coming out of the state machine, before we plug into the output pose, we want to make sure that we have a slot to play the animation montages in. So search for default slot. And then we'll wire this in. And then let's go ahead and open up our locomotion state machine. And out of the entry, we're going to create a new state and call this idle. And this should work for now. Let's go ahead and create some animations for our character. And there we go. Next, I'm going to convert these animations into montages. So if you select them and you right click, go to create animation montage, that should work. Now, so let's go into our data asset that we created for our AI, which is up here. And if you remember, we created an array for attack animations. So if we hit the plus icon, we can add these new montages that we just created as attacks to play. I'm going to hit save, and then let's return to our blueprint here. So now we can set up some logic for when the character attacks to play an attack animation. Let's go ahead and clean this up a little bit first. What I want to do, I'm going to select each one of them and collapse them into a node. This one is, which one is this one? Patrol. This one is move to target. This one is make decision. And so now, cleaned up a little bit of clutter. So out of our attack, we want to make sure to set our AI states to stop brain. And then we want it to play the montage, so we'll search for play montage. And I like to use the play montage node instead of the play animation montage because we have a little more control with it. Let's go ahead and assign our AI skeleton to the montage. And then here we can actually start setting some variables to be used inside of our blueprint using our data asset. So if we move over here, we started to mess with this a little bit. Let's go ahead and promote the health variable. I'm going to search for attack animations and also promote that to a variable. And while we're at it, let's just go ahead and get the rest of the stuff that's in here. So we have our attack animations, we have our default movement speed, patrol animations. patrol animations, promote that to a variable. Hit reactions and death animations. Okay. And then we also want, I believe it was default movement speed. Fix this up real quick, keep it nice and organized. Default movement speed. Promote to variable. So actually I'm going to move this over here to the left. So, and then I'm also going to wire this up to event begin play. So what we can do is once we set our default movement speed, we can get our character movement component. And then if we search for set max walk speed, we can set it here at the start. You just wire that straight into it. And so let's take this and wire it back into our timer here, and then we can collapse this into a function. So if we select all of it and we select collapse to function, we can name that function set AI variables. We can move this back down here. So now that we have our variables set inside of our blueprints, we can get our attack animation. And then out of this array, we can do random array item. Let's go ahead and promote this to a variable and call it attack animation. Set it up and then plug in attack animations into our montage. And then after we play the attack, we also want to duplicate this AI states and then have it make the next decision. Okay, so let's give it a shot and see if it works. Ah, silly me. So I made the animation blueprint, but then I forgot to assign it to our skeleton. So if we go to mesh, and then if we go over here, we can search for ABP, new AI, and now it should work. Okay, it spotted me, it's coming over. He's moving kind of slow, but that's alright. And then there we go, played the animation. Okay, so now let's hop into some more fun stuff. Let's start doing damage and health, and then a few more variables to determine what to do. So let's go ahead and add a, I'm just going to search for damage, and then we're going to add event any damage here. Okay, so what we also want to do, we want to get our health variable that we created, and then we want to subtract health every time it receives damage. And then we want to set that to health again. So each time it takes damage, it subtracts it and sets it as the new health. And then with this, we want to check and see if it's less or equal to 0. And if it is, that means the AI has died. So let's go ahead and create a new variable and call it death, question mark, and make sure it is a Boolean. And then we're going to drag that in and set it to true. And so here we can play our death animations. So let's go ahead and create a new montage. So play montage. And then we can get our death animations array here. And then same thing, we're going to get random array item. Promote this to a variable, call it death animation. And then one thing that we want to make sure that we do if the AI has died is we want to make sure that we stop this timer so that it no longer keeps firing. So we're going to get this AI brain handle. And then we're going to search for clear and invalidate timer by handle. And that will stop our timer. Here we go. Let's go ahead and assign the mesh as well as the death animation. And then here, coming out of this, if it's not equal to 0, that means that he's still alive, which means he's going to take damage. So what we can do out of here, we're going to do get hit reaction animations. And then we'll do random. We could also do it by the direction the AI gets hit in. We might do that later, but just for now, I'm going to promote this to hit reaction animation. So there we go. Same thing, play montage. Assign the skeleton, as well as hit reaction animation. And so after they have received damage, we want to make sure that we have the AI make a new decision. So we're going to get our AI states, and then same thing, make decision. And then we also want to make sure that there is some kind of threshold for when they take damage. Because if you're using something like a machine gun and you're hitting the AI, you don't want them to play a reaction every single time, or else they won't ever be able to get to the player. So what we need to do is to create a threshold. We can do that by getting our health. Well, actually, what we can do is scooch this over, and I'm going to promote damage to a new variable and call it incoming damage. And then we want to make sure that it gets added to each time, right? So we're going to take our incoming damage, we're going to do add, and then add to it. So each time this value is going to keep going up. We can get our incoming damage, and then what we can do is ask if the incoming damage has reached a certain threshold, right? So if it is greater or equal to a certain value. So let's say the AI takes, like a damage of 30, right? Let's go ahead and promote this to a variable, and we'll call this hit reaction threshold. Okay, so if it is greater than this threshold, what we want to do is take our incoming damage and reset it. That way they can restart the cycle. And then we can play our hit reaction here. Okay, let's start to tackle a couple more of these, like the face target, the dodge, the strafe. So let's do the dodge first. So if we want our character to dodge, we want there to be a certain percentage chance of them doing it. And we can actually do that if we go over here, coming out of our incoming damage boolean right here. What we can do is we're going to do a search for random float in range. So we're going to leave the minimum value to 0, and we're going to set the max to 100. So it's going to get a random number between 0 and 100, right? And so what we can do is whatever number gets generated, we can ask if it is less than a certain value that we want it to be. So let's go ahead and pull out and do a search for less or equal to. Let's go ahead and promote this to a variable, and we'll call this odds to dodge. And so say we wanted there to be a 20% chance. Actually, let's make it 30% chance for our enemy to dodge our attacks. All we would have to do is type in 30. And then we can just wire that into here. And then we would set our AI state to dodge. Very simple. Okay, so if we go up here to where our dodge logic will be, remember the first thing we need to do is stop the brain. And then let's go ahead. So there's two ways to do this. One is if you have a root motion animation that will actually make the character dodge, you can just play the animation. Or if you don't have that and you just have like a regular animation without any root motion, we can code that dodge logic in manually. And so to make the AI dodge, the first thing we need to do is get our actor's location. And then we want to get the right vector of the actor, which is essentially just the through line of the y-axis, right? Where's that x? Yes, the x-axis. So to do that, we're going to right-click, and then we're going to search for get right vector. Or actually, get actor right vector. There we go. That's what we need. So what we can do, if we get our actor right vector, we can pull out of here and we can multiply this value by a float value. So if you right click on this bottom pin and then search for to float, it will convert it to a float value. And then we can promote this to a variable here. And then this will essentially be the distance that the AI dodges from left to right, right? So we'll call this dodge distance. And then what we do, we're going to add this value to our actor's location. So we're getting the actor's location, we're getting the right vector, and we're defining how far the movement should be. So then what we should do is create a timeline. Let's right click, search for a timeline. And I'm going to name this dodge timeline. Let's open it up. And I'm going to set the length to 1. And then we're going to add a float track. I'll just call this something like alpha. Oh well. And then we want to set 2 keyframes, one at 0 and then another one with the time set at 1 as well as the value at 1. And then usually, like for a dodge animation, it starts off faster and then it slows down as they're going, right? So the initial dodge is really fast and then it will kind of settle into the location it moves to. And we can do that with the timeline if we select both points and convert to auto. And then we can move this beginning one this way. Essentially, the steeper the line is, the faster it will move. So it'll go fast and then it'll slow down over time. So go ahead and save that. So now let's do set actor location. Plug it into the update, and then we're going to search for lerp vector. And so we're going to plug our alpha value into the alpha of the lerp vector. And then let's just go ahead and plug that into here. So now we essentially need to assign two different values here, right? So the first value is essentially going to be the current location of where the AI is at. And what we can do is promote this get actor location to a variable and call it start dodge location. And then we can promote this variable for where they'll end up to be end dodge location. We'll go ahead and plug those in. Plug it into the timeline. And we'll go ahead and assign those variables. There's the start. Here is the end. Okay, and then once the dodge is completed, we need to make the AI make a new decision. So we'll go ahead and set the AI states to make decision, and that should take care of that. Okay, so let's give it a test. Oh, actually, we forgot to change this to dodge here. So there's a couple more things we need to do before we can test it. The first thing we need to do is assign a value to our dodge distance. So if we select that and put in a value, I've gone ahead and set it to 300. And then typically, like whenever a character is dodging, they're invincible, something like the Souls games. So what we can do is create a new variable, and I've already gone ahead and done that. I've called it dodging. So whenever dodging starts, we're going to set it to true. Whoops. And then whenever it's finished, we'll set it to false. And then coming out of the take damage, we can just put it into a Boolean here. So if the character is dodging, they can't take any damage and they're temporarily invincible. And then we can also use this here. So if it continues to happen, we don't want them to dodge like a whole bunch of times. We want them to dodge after they finish dodging the first time. So let's go ahead and create another branch here before the dodge logic. So if it is dodging, then it can't go through and play again. And if it isn't dodging, it's going to start dodging. Okay, so a couple things we got to change here to get this thing working. So we forgot to assign a value to our hit reaction threshold here. So let's go ahead and set that to a value of 50. There we go. And then I actually want to move the odds of dodging to a different location. I want to add it after here and before the hit reaction, right? So let's go ahead and plug that in. So coming out of the false, there we go. So if he's not going to dodge, then he's going to take damage, or if he's not going to dodge, then he's going to play the hit reaction. If he is going to dodge, then it's just going to dodge, and then it's not going to play the hit reaction. Okay, let's give this a shot. want to change that so it's a little more randomized, so that we can do that real quick here. So if we go here, we're going to use that same random float and range kind of technique to determine which direction to dodge. So same thing, we'll do search for random float in range 0 to 100. And then we'll do less or equal to. And then we can essentially just set this to 50. So there's a 50% chance of them dodging left or right. And essentially what we're doing is we're going to set this dodge distance negative or positive. So I can do that by doing this. I'll do positive 300, negative 300. I'm going to clean this up a little bit. How it dodges. The odds are a little too high though. So let's dial that down a little bit. So this odds to dodge here, it's at 30. Let's do something, maybe like 15. That seems reasonable to me now. I might even turn it down a little bit more, but that works for now, so let's continue. One thing that we might want to do as well is have the character or have the AI face the player whenever it dodges, so that it's kind of perpendicular with the character. And we can do that right before we play the timeline. All we have to do is set actor location, or actually set actor rotation. We're going to split this structure pin for the new rotation. We're going to look at rotation. Same thing here, and we're going to plug in only the Z. We'll do get actor location for the start, and then for the target, we're going to do the same thing, get actor location. Okay, cool. So that takes care of our dodging. Let's move on to the next thing. Actually, let's collapse this into a node first. Keep it nice and organized. Do dodging. Okay, so for this face target right here, typically you'd use that like after they've made an attack, and you'd want them to kind of smoothly rotate towards the character again. So we can do that real quick. We can essentially just take this logic we just created here and copy that. We go back out here. Always remember to stop the brain. And we're actually going to create a new timeline here. So timeline. We'll call it face player timeline. going to set this to 1 second. And there's a reason I'm setting it to 1 second, and I'll show you guys why later. Call that alpha. Zero out the values for the start. Time 1. Value of 1. And then let's do an auto. Select both points and set the curve to auto. We're going to do a search for lerp rotator, or lerp rotator. Let's do shortest path checked. And then we're going to split the structure pin because we only want them to rotate on the Z. I'm going to move this over here. And make sure to plug it into play from start. And I'm actually going to recombine this structure pin, so if you right click on it you can also recombine it like this. Let's search for get actor rotation, promote that to a variable, and then we'll set this to, or we'll call this current rotation. And then we'll promote this one to look at rotation. Plug that into the start. Make sure you plug in the update into the actor rotation. Let's assign these variables. So it stops the brain, it rotates. We're going to duplicate this, and we're going to set the new state to, you guessed it, make decision. Go ahead and save it, and I'm going to go ahead and collapse this into a node. What should I call this one? Face target. Make some space for it. We'll go ahead and collapse our attack into a node as well. Whoops. Okay, so what we can do now is whenever the AI has finished attacking, instead of doing make decision, what we can do is have it face the target again. That way, whenever it goes through face target, it's going to rotate the AI towards the player, and then it's going to make a decision. And so now I'm going to show you guys why I made the time on the timelines set to a value of 1. And the reason I did that is if we set it to a value of 1, we can control the rate, its play rate, very easily. So if we go back into our event graph, and let's go ahead and open up our set AI variables here, right? I'm going to move this over here. If we look at our components variables inside of our variables here, we have our dodge timeline, and we also have our face player timeline. So if we pull out of these and we do set play rate, we can define play rates here. And so one cool little trick here is if we take our input into the new play rate and we search for a divide, if we set this top value to 1, we can, whoops, whatever we put in here, it's going to adjust that value proportionally to the value of 1. So let's say I only wanted it to be, 0.5 seconds instead of, the full 1 second, then that will take shape that way. And what we can also do to kind of give us a little more control is we can promote this to a variable. We'll call this Dodge play rate. Let's go ahead and do the exact same thing over here real quick for face player timeline. Set the top to 1. Promote this to a variable. Face player play rate. So now, if we go into our data asset that we created for our AI, we can create variables for these and set them this way. So if we go into here, we'll create a new variable for dodging. So dodge play rate. Make sure it's a float and make sure it's a single and not an array. And then we'll do face player or face target. That's better. Play rate. I'm going to move these up here, keep it organized with the other floats. So dodge play rate, if we go into our data asset for the specific AI, we can set those parameters here. So for the dodge play rate, we'll do like 0.7, just as a guess right here. And then for the face player play rate, actually 0.7 would probably be, we'll do like 0.6. That's probably good. And then if we go back into our AI here, go ahead and pull those out. Dodge play rate. And then we'll set it. I'm going to scooch this down and do the same thing for face targets. There we go. And then what's great about doing it with data assets is we can control essentially any variable that we want to with this. So if we go back into our AI, we can also create one for odds to dodge and set that up that way. We could also create one for hit reaction threshold. So let's go ahead and do that real quick. Keep them organized. Go into here. We'll set our odds to dodge. I believe it was at 15. And then our hit reaction threshold, I believe, was at 50. And then if we go back into here and back into our set AI variables, odds to dodge. Reaction threshold. Okay, cool. So that takes care of that.